All right. So we should be at this point in N1. And if you will go to the next example, we're going to go through the rest of them in this section together. Okay? So for example 4, integrating functions, we're going to look at the function. Let me see if I do. Let's do this function. Y equals the integral of e to the negative 2x dx. Okay? Now, again, because we have an inside function, we're going to use u substitution. So we're going to let u equal my power here, because that's my function of x. Du then is negative 2 dx, and I have to replace, notice there's no negative 2 hanging around, so I have to replace dx with something that's just dx, so I have to divide by negative 2 here to get negative 1/2 du as a replacement. Now I'm going to rewrite it into the view. Okay, so we have e to the u, and then I'm going to replace dx with what dx is equal to, which is negative 1/2 du. Bring the constant out in front. And the integral rule, this is the derivative rule, remember, e to the u du, or e to the u prime. And so what we'd have had originally is just e to the u. So that's what we have here, 1/2 e to the u, c. And then our last step is to replace the u. And you're done. Okay, it is helpful, again, to remember that this is the derivative, and then we're looking for the original function. So if you know your derivative rules really well, you should be able to recognize, oh, that's the rule for e to the u. And then you can back it up. Okay, go ahead and flip it to example 5. And we're going to look at this function here, a bit more space. Y equals the integral of sine to the 6x times cosine, and this is all grouped together here, plus e to the negative 3x dx. Okay, so this is another situation where we can integrate this by hand using u substitution, but we're going to break it up into 2 separate ones and then work them both separately. Okay, so let's do that. If we write it as the integral of sine to the 6x cosine x dx, then add the integral of e to the negative 3x dx. Remember, that's one of the rules that we can do is, you can, if stuff is being added or subtracted up here, you can break it up into 2 integrals and deal with each one separately. I'm going to integrate this one first. I'm going to have to let u equal either sine or cosine. Well, since sine is the one that has the power on it, I'm going to let u equal sine. And also, because I know my derivative rules really well, I know the derivative of sine is cosine. So when I find my du, I get cosine x dx, which I have there, so I don't have to be fancy. I have a direct replacement for that now. I'm going to rewrite this one. U to the 6th x, u to the 6th x dx. Du, I'm turning the view. Okay, so this gets replaced by a u, so I go to the 6th. And then cosine x dx gets replaced with du. Alright, now let's do the u substitution over here. This time I'm going to let u equal my exponent, because that's my inside function. Du is negative 3 dx. There's no extra negative 3 hanging around here, so I have to move it to the other side. So I get a good replacement, and then I'm going to rewrite this one. Okay, so I have e to the u, and then the dx gets replaced, substituted in for by negative 1/3 du. Okay, and now we're going to integrate both of these. This one just uses the straight power rule for integration, so I'm going to add 1 to the exponent and divide. So I get 1/7 u to the 7th plus c. And then here, the integral rule for e to the u, du, is just e to the u. So we have negative 1/3 e to the u plus c. Now, in your final answer, you do have to replace your u's and keep straight which u goes where. So in this one, I have 7th sine to the 7th. And I'll tell you what to do with c here in a minute. And then over here, I have negative 1/3 e to the negative 3x. And then you just need 1 plus c, because essentially, whatever these two constants are, they would add together anyway to get just one value. So we just write it once. All right. So you've already seen that an integral has many solutions because depending on what the c is, you can get tons of different graphs. In many applications of integration, you are given enough information to determine what we call a particular solution. So that's when we find z. These are the problems like we did before when I give you the acceleration and you have to find the position function. To do this, you need to only know the value of y for one value of x. This information is called your initial condition. Okay? They have to give you an initial condition if they want you to find a particular solution. Okay, so let's start with one example here. I'm going to give you a derivative. So f prime of x equals the square root of x plus 1/2, and we'll just put a square root of x underneath here. And we're going to find the particular solution when f of 1 equals 0. Alright, now notice I didn't set up an integration, but this little phrase, find a particular solution, that's code, or that indicates that you need to integrate, especially if they give you a derivative and they want you to find a particular solution. And notice the value that they give you isn't f prime, it's f. So this is talking about the original function. So I'm going to have to integrate this. Now, before I do, I'm going to rewrite it as exponents because it'll be a little bit easier here. And then I'm going to integrate it. So keep in mind that you can integrate both separately because you're adding them together, which is how I'm going to set it up here. Or you can keep them together and then just integrate both. We don't have to use substitution here because you don't have an inside function. You just have x raised to a number power, so we can just use the power rule for integration here. Alright, so whatever I get when I integrate this is going to be my original function, or capital F of x. So I'm going to add 1 to the exponent and divide. When I add 1 to the exponent here, I get 3/2. When you divide by 3/2, it just flips a fraction to get 2/3. Okay, the same thing here. I'm going to add 1 to the exponent to get 1/2. Dividing by 1/2 flips it. So you get 2/1 times 1/2, or just 1. Okay, so there's my original function. Now I need to find my particular solution. This is basically integrate to find c. Okay, so x is this is saying when x is 1, my y is 0. Okay, so I'm going to plug in 0 for y, 1 for x to find c. Alright, so this gets me 2/3. This gets me 1 when I calculate it out. So this is 1 2/3, or 5/3 if you get a fraction like that. And so I'd have to subtract it to the other side, so you get c equals negative 5/3 at the end of that. If you need to write yourself a little note here, use 1, 0 to find c value. Okay? And then we're going to rewrite my answer. So f of x, 2/3 x to the 3/2 plus x to the 1/2 plus, minus 5/3. So that's my particular solution. Okay. Sorry, I just noticed I got a phone call there. Alright, go ahead and flip. We're going to do one more together, and we'll do example 8 together on Monday, or whenever we get to it next. Alright. Actually, let's do example 7 and 8. I'll give you a short video for this weekend. We'll do example 7 and 8 together on Monday. That'll be a good review of integration. We'll do easier ones and then go from there. Alright, that is it. Have a good weekend.